Okay, for this video, I'll be going through Kinematics Tutorial 3. Okay, question 1. The figure below shows the water level in a well on a wet day and a dry day. When the well is dry, a stone was dropped from rest. So this is important. From rest means initial velocity is 0. At the top of the well, the stone took 3 seconds. So this is our t. To hit the bottom of the dry well, so this is the case here. So this is t equals to 0 and t equals to 3. It takes this time to drop to the bottom of the well. Assume that g is 10 meter per second square, so this is actually the acceleration. And because the motion is downwards, okay, and the acceleration is also in the same direction, okay, and it's given a positive value of 10, so we can take downward motion as positive, okay, and upward motion, although in this question there is no upward motion, but we still can set the upward motion to be negative, because some students will be asking, do we set the downward motion as positive or negative? So sometimes the question may give you that value. Sometimes you can decide for yourself, alright? So in this case, we take downwards as positive. So they ask us to calculate the velocity of the stone just before it hits. Just before it hits, it doesn't mean that it's 0. It is not 0. It should hit with a certain velocity, okay? So it's just before hitting. So that means the velocity at t equals to 3. So we have this formula, a equals to v minus u over t, because we have our a here given. We have initial velocity to be 0. We have time, 3 seconds, and we are supposed to find v. So you should get 30 meter per second. Now they want us to calculate the depth of the well. You may sketch a VT graph. Now, one common mistake is that some students actually thought that this 30 meter per second was for 3 seconds. That means it has a constant speed of 3 seconds. However, actually initially the velocity is 0 and it keep on increasing every second by 10. So by the end of 3 seconds, so maybe I can write it over here. So at t equals to 0, the v equals to 0. T equals to 1, the velocity would have become 10, because that is your how much your velocity increases, that is your acceleration. T equals to 2, v equals to 20, t equals to 3, v equals to 30, t equals to x, v equals to 10x. Okay, so on and so forth. But we don't have to do this kind of working. We can actually use the formula, which is this a equals to v minus u over t. So you will see that actually as time goes by, if there is acceleration, the velocity will increase or change as well. So some students actually use depth, which is the wrong answer. I write down first. Depth equals to 3 times 30. So this is the time duration and this is the final velocity. But it is not moving with constant velocity of 30. It actually went from 0 and it increases all the way to 30. Okay, so they offer a hint here, sketch a VT graph. So VT graph, V versus T graph, initially at time equals to 0, the velocity is 0. At time equals to 3, the velocity increases uniformly to 30. That means the acceleration is actually 10 meter per second squared. So, two things that are important about VT graph. The first one is that gradient represents acceleration, which is what is being said here. And the second thing that is important is that the area under the graph equals to distance traveled. Okay, so since we have already used this in part A, we are going to be using this concept in part B, which is finding the distance, which is finding the area. And you see that it's actually the shape of a triangle, right? So it should have a half times base of 3 times 30. So you should get 45. Most common error is this error of 90, which is incorrect. Okay, so by the way, there is also some students who actually did it by formula instead of using a VT graph. Okay, there are 2 additional formulas that may prove to be helpful to you. But if they say solve by graphical method, you must draw a graph. You cannot use this formula, but this formula you can use it for checks. Okay, so the first one is S equals to UT plus half AT square. And S is actually your displacement. U is your initial velocity. A is your acceleration. And your T will then be your time. Okay, later on I'll show you how to use it. The other formula that you can try to use is V square equals to U square plus 2AS. Okay, V is your final velocity. Okay, U you should know, A you know it already, and S is your displacement. Okay, so which formula we use depends on what information is given. Okay, we can try to use this calculate the depth of the well. Okay, because let's say you don't want to draw a VT graph. What are the information that was given? We know that the initial velocity is 0 meter per second. We know the time is 3 seconds. We know the acceleration is 10 meter per second square. So if we have U, T, and A, right? And because part A asks us to find our final velocity, we also know that the final velocity is 30 meter per second. Okay, so maybe I can do method 1 using this formula. S equals to UT plus half AT square, and S is the distance moved, so it will be our unknown. U is 0 multiplied by T plus half 10 T square is 3 square. Okay, so our displacement is 0 plus 5 times 9 equals to 45 meters. Okay, so we can actually find what is the distance traveled or the displacement. So if you want to use formula 2, you need to have your V, your U, A, and S is our unknown. So because our V is 30, so 30 square equals to U squared 0 square plus 2 times A, and this is our displacement. So this is 900 equals to 20S, and therefore S will be 45 meters. Okay, so these are the formulas for kinematics, but if they ask you to do by VT graph, you have to do by VT graph. Okay, next part of the question, part C. On a wet day, a stone dropped from rest. Okay, so drop from rest, U equals to 0. At the top of the well takes 2 seconds before it hits the surface of the water because it is wet. So if we look at the diagram here, it only went from T to T equals to 2. Okay, so it's a shorter distance traveled before it hits the water. They want us to determine the depth of the water from the bottom of the well. So again, they ask us to sketch a VT graph. So this is our VT graph. So instead of at 3 seconds it reaches 30, now it's only given 2 seconds to reach velocity of 20. Okay, so again you can find your area under the graph, which then is equals to half times base times height. So you get 20 meters. But take note, they want us to determine the depth of the water from the bottom of the well. Okay, so just now, if it's a dry well, it is 45 meters. But now, because there is water, and from the top to the water surface, it's 20 meters. So therefore, I will need to take 45 minus 20 to find the depth of the well. So it is 25 meters. Okay, question 2. A hammer was dropped by an astronaut on the moon. Figure 2 shows the velocity time graph of the hammer. They want us to calculate the acceleration of the hammer due to gravity. Okay, so we take downwards as positive. Okay, because this graph is given VT graph, and the gradient represents acceleration in a VT graph. Okay, so always check that your graph, what you're dealing with, is it a VT graph or a DT graph? So for VT graph, the gradient represents acceleration, and you see that this gradient is a positive gradient, and the hammer was dropped downwards, right? Downwards. So if the gravitational acceleration is positive and is acting downwards, therefore motion is downward motion is positive. That's why over here take downwards as positive. So in this case, because the graph is given, we have to take downward as positive. They want us to calculate the acceleration of the hammer due to gravity. So VT graph, I'm repeating, there are two things that are important. Firstly, the gradient represents acceleration. So if you know this, you would be able to find the acceleration by finding the gradient. And we know that this gradient is actually by a straight line, and it's not flat, so there is a positive gradient. And because it's a straight line, therefore it will be a uniform gradient. Uniform gradient. So you can take any point. Let's say I take this versus 0, 0. I should get the gradient, so I'll be using that. But do take note of how much each small square is. So there are 5 squares here from 0 to 0.4. So 0.4 divided by 5, each square will be 0.4 divided by 5 equals to 0.08. So there's one square, so this is 0.48. 0.48 over 0.3. I will get an answer of 1.6. Okay, so even though the answer uses 2.08, which is over here, and using the time of 1.3 using this gradient triangle, okay, however, because it's a straight line and it's plotted quite accurately, even though I use this point here, 0.3 comma 0.48 versus 0, 0, I can also get the gradient to be 1.6 meter per second square. So that's the first thing that you need to know for VT graph. Then you see the height which the hammer falls in the first second. Okay, let me clean this up a bit. So the other thing that's important about VT graph is that area under the graph equals to distance traveled. Okay, so they want in the first second, so I must go to the first second, and I need to know what is the area. Okay, basically it looks like a triangle. So again, you cannot go to 1 second and then you say that the velocity is 1.6. Therefore, it has a constant velocity of 1.6, so it is 1.6 times 1. Take note, within this 1 second, it did not reach 1.6 until at 1 second. Before that, it was all lesser than 1.6. Alright, so if you just take velocity times time, it is incorrect. Okay, rather you need to use this concept. Area is the distance, area under the graph is the distance traveled, which actually is a triangle. So if half times 1.0 times 1.6 equals to 0.800, I leave it to 3SF for my answer. Okay, at 1.3 seconds, the hammer lands on the ground and penetrates into the soil. So it decelerated uniformly or constantly. That means later you need to draw a straight line. Okay, for 4 cm before coming to a rest. So the final velocity becomes 0. Okay, so at 1.3 seconds, let's take a look. 1.3 seconds is over here. Okay, the velocity. So if you're talking about this question, then we can say the initial velocity at this 1.3 is 2.08. Okay, and it's going to reach a velocity of 0, and it's going to be a straight line. Okay, so I'm just drawing this. Currently this straight line is not correct. It's not correct, but I'm just representing the question with initial speed of 2.08 at a time of 1.3. Okay, and after some time, it will reach a speed of 0, final velocity to be 0, and it must be uniform deceleration. So I need to draw it with a straight line. Okay, what other information is given? They say that the hammer decelerated constantly for 4 cm. Okay, so this 4 cm, I need to change it to 0.04 meters. Okay, 0.04 meters. That means this triangle here that I have drew, it must represent a area of 0.04 meters because that is the distance traveled. Okay. So that's why I say my answer, this one is not correct yet because I don't know that what time it reaches. Okay, so I need to again use the area under the graph equals to distance traveled. So the depth of penetration, they want us to calculate the time taken, okay, for the hammer to decelerate after hitting the ground. That means from speed of 2.08 to speed of 0, what is the time taken? So the depth of penetration is 0.04 meters. I'm using the area under the graph equals to half times t times 2.08. So the time taken is 0.0385. Earlier on, I actually introduced two kinematics formula. S equals to ut plus half at square, and v square equals to u square plus 2as. Okay, I can only use this because I know the final velocity is 0. I know the initial velocity is 2.08. Do I know the acceleration? I don't know as well. Do I know the distance traveled? I know, which is 0.04. Okay, so I can use this to find my acceleration or deceleration, right? And with that, then I can go back to use this formula, s equals to ut plus half at square, because once I know I have this 0.04, I don't know my time, I know my initial velocity, I know my acceleration from below, right, from here, and then I can find my time. So you see, if you were to use the formula, you may need these two formulas to work together. Okay, but if you were to draw a VT graph, it will be more straightforward. Okay. Okay, so you may want to try these two formula. Okay, but the trick here, take note, is this 0.04 meters. You need to convert your 4 cm. I see some students just use 4 cm as it is, okay, because then the units won't tally. Next, they want us to calculate the deceleration. Once you have the time, you can then use this formula, a equals to v minus u over t, to find the deceleration. Now, take note, deceleration can only be positive, okay? Acceleration can be positive or negative. Deceleration can only be negative. Positive. Okay, question 3. A bullet is fired vertically upward from a gun which is held 2 meters above the ground. So let me do a sketch. This is the gun. This is the ground. And let's say a man is holding on to it. So this is the gun, okay? So it is held 2 meters above the ground. The bullet reaches its maximum height in 4 seconds. It is fired vertically upwards, right? So it will go up and it will reach maximum height within 4 seconds. Okay? Within 4 seconds. So at t equals to 0 seconds, it is here. At t equals to 4 seconds, the bullet is over here. When it's reaching its maximum height, or when it has reached its maximum height, the velocity will be 0, right? Because if there's still velocity, why doesn't it continue to go up? Okay. Then they say take g as 10 meter per second square. So again, we need to take downwards as positive because g is always acting downwards, and it is given a positive value of 10 meter per second square. That means the motion of downward motion, it is also positive. That means going up motion will be negative. Okay, so calculate the initial velocity of the bullet. So we have our A and it's positive. We know our final velocity is 0. We need to find our initial velocity. We have t equals to 4 seconds. So they use A equals to v minus u over t. And A is 10. Final velocity is 0. Initial is unknown over time of 4 seconds. So u equals to minus 40 meter per second. Why is it negative? Because the bullet is going upwards and upward motion is negative. Why do we say upwards motion to be negative? Because downward motion is positive. Why is downward motion positive? Because the g, which is acting downwards, it is positive. So therefore, u, which is negative, is going upwards, which makes a lot of sense. Okay, they want us to calculate the total distance of the bullet traveled by the time it hits the ground. So this bullet, when it goes up, then it will come down. But now they want it to actually hit the ground. But they want us to calculate the distance traveled. Okay. So we can actually draw a VT graph. Okay. So because our initial velocity is negative, remember we must start at the negative, and it is a constant acceleration or constant deceleration, right? So it must be represented using a straight line. Okay, and the time taken to reach 0 velocity is 4 seconds. So we can then find the area under the graph to find the distance traveled, because they want us to find distance traveled. So it will be half times 4 times 40. Okay, so why did I drop the negative? Because now they are finding distance. No need for us to talk about displacement. No need for us to talk about direction. So we'll get 80 meters. Okay, and once it's up there, once the bullet is up there, it will then be subjected to a downward motion due to gravitational acceleration. Okay, so it will now be traveling downwards, and we say that downward motion is positive, so it will continue like that with the same gradient of 10 meter per second square. Okay, because the gravitational acceleration remains the same. Okay, so there will be an additional 2 meters to it, and before that it will reach the hand or the gun that fires it, right? After another 4 seconds, because gravitational acceleration is the same. So you have to add on the 2 meters. So 80 plus 80 plus 2 meters. Okay, question 4. At the top of the waterfall, which is here, a fish jumps out of the water with a vertical speed of 4 meters per second. So if it jumps up, right, vertical speed, and is given a positive value, therefore upward motion will be positive. Downward motion will then be negative. So it reaches a maximum height of h before falling down to the base. Take g as 10. Okay, sorry. So they want g to be 10, but you can also take g to be negative lah. Okay, the plus and minus actually depends on which direction of the motion you want, but because this the workings are all taking downwards as positive, let me switch this. Upward motion will be negative, downward motion will be positive. Okay, so this is how we deal with the sign. They want us to calculate the time to reach the maximum height. Okay, so at the maximum height, okay, the final velocity is 0. The initial velocity, because it's going up, and up is taken as negative, so it's a negative value of minus 4. okay? And time is unknown, and gravitational acceleration is taken as 10 meter per second square. So our A is 10 meter per second square. So sub into the formula. Let me just work it out. A equals to V minus U over T. A is 10. V is 0. U is minus 4. So it's 0 minus minus 4 over time. Okay, so time will then be 4 over 10 equals to 0.400 seconds in 3SF. Take note, the time cannot be negative. Okay, velocity up down can be positive or negative, but time will never be negative. So if you are getting a negative time, that means somewhere your sign you have to change it. So they want us to calculate the maximum height. Okay, and again we can use a VT graph. Okay, so initial velocity at time equals to 0 is actually minus 4. Why is it minus? Because it is going upwards. Okay, and how long does it take to actually reach a velocity of 0? Is 0.4 seconds. We calculated from part 1. And displacement is the area under the graph. So it's equals to minus 0.8. But why is there a minus now? Because it is going upwards. When it's going upwards, right, it is treated as negative. But now they're asking for height, which is not displacement. So this is a scalar. So all we need is to take the magnitude. Don't have to care about the direction. But the negative tells us that our sign that we have been using is consistent. Now, from the maximum height, the fish took 4 seconds to reach the base of the waterfall. So let us see the diagram. So from the maximum height, it took 4 seconds. Okay, so if I were to talk about this part of the motion, right? So here the U will be 0 meter per second. Okay, then there will be a final velocity, which I don't know, but I know the downward motion is positive. I know the G is going to be 10 meter per second square positive. I know the acceleration is 10 meter per second square. Okay, so calculate the velocity of the fish upon entering the water. Just now we say the U is 0, the V is unknown, the A is positive 10, the T is 4 seconds. So we can actually find V equals to 40. And this V equals to 40 is actually positive, right? It's actually positive in value. And we just now chose downwards to be positive, right? Downward motion is positive, so it tallies. It is a positive velocity. Now they want us to calculate the height of the waterfall. Okay, so you see that we are constantly using a gradient to find acceleration. We are constantly using area under the graph to find the height, and we will be testing you all on all this. So the height. So again, we can draw a VT graph. So we can start from scratch. They want us to find the maximum height of the waterfall. So we can start from scratch because now it's actually going downwards. The fish is going downwards. Initially, the velocity is 0. Then the final velocity is actually 40 from what we have found over here. The time taken is 4, and we know that the acceleration is 10 meter per second squared. So at time equals to 0, velocity is 0. At time equals to 4, the velocity is positive 40. Okay, because we set downward motion to be positive, right? And this gradient will actually give me acceleration of 10 meter per second squared. Now we need to find the area under the graph, which is actually the distance traveled by the fish from its maximum height to the bottom of the waterfall. And we get this area of triangle of 80 meters. Okay, I saw some students actually omitting this half. They thought that the fish keep on moving with a constant speed of 40. It is not true because it actually accelerated from 0 velocity to 40, right? So you cannot be just using this distance equals to speed times time. Okay, always check that the velocity is constant before you can use this. If not, you cannot. You have to use area under the graph. Okay, so is 80 meters the final answer? It is not. because we have to subtract the height of the waterfall. Sorry, the height that the fish is above the ground, which was 0.8. Okay, so have to read the question. It's still the same question. Okay, so how about, can we use other formula, s equals to ut plus half at square? Okay, which we can. U is actually 0 multiplied by t, which is t is not 0. T is actually 4, but 0 multiplied by 4 is 0. Plus half 10, and t again is 4 square. Okay, so equals to 5 times 16 equals to 80. Okay, we still get the same answer of 80, but you still need to subtract away this minus 0.8. Okay, I'm not saying that you cannot use this formula. Okay, some of you may want to use this formula, but in the question, if they do ask for you to solve graphically by drawing a VT graph, you have to do that. Okay, so example, part C, sketch a velocity time graph of the fish from the time it leaves the water until it reaches the water. Okay, so if you put downwards as negative, this part of the motion from here all the way to here, they are positive. It is, sorry, downward is positive. So all these are downward motion. Okay, this part, it is negative, right? Because it's negative velocity and negative displacement. So this part is where the fish goes up. Okay, so 0.4, and finally, how long does it take to actually reach a speed of 40 meters per second? It is 4 seconds. So 0.4 and 4.4. Okay, now what if somebody set downwards to be negative and upwards as positive? Then they will have the reverse. Okay, upwards as positive, so they will have positive 4. Okay, then velocity, it will be like that. It will take 0.4, 4.4, and the final velocity will become minus 40. Okay, because you set downward to be negative, but for my solution, we set downward to be positive. Okay, so if you are having this shape of the graph, you are also correct. Okay.